Okay, good morning, guys. I am going to do today through a video that you guys can replay and as you need, I guess. So today's lesson is going to be 5.9, and it's multiplying fractions for an algorithm, which we have been discussing the drawings quite a bit in the last week with all this multiplying, and we've noticed the patterns and kind of already discovered the algorithm. Your goal today, as I posted on your checklist and on your calendar, is going to be to figure out how to use the algorithm, how it works, and of course, most of all for us guys, is where does this algorithm come from, okay? So in this video, I'm going to go through that goal to show you how it works with the question 3/4 times 2/3, okay? Just because we're away from school too, I don't want you guys to lose your reasoning and your logic, right? That is our number one skill that we are developing, and most important as a problem solver and as a thinker. So when you look at a problem like this, I want you to say to yourself, well, 3/4 is not a whole thing, it's a part. And 2/3 is the same. It's not a whole thing. It's also a part. And the word multiply can be substituted out for the word of. So really, we have a part of a part. And for that reason, I can think logically and I can say, since I have a part of 2/3, my answer should be a number less than 2/3. Multiplying, you can do that turnaround fact too. So we could read it opposite and we could say we have a part of 3/4. So I know my answer is going to be less than 3/4 as well. So I know my answer should be somewhere between, or something less than 3/4 and something less than 2/3. It's a part of a part, okay? So just keeping that in mind to give us an idea of what our answer should look like when we're all done here and whether or not it makes sense. Which means if you have anything over the answer of 1, something is wrong with your answer. So that's first of all. We found out through our patterns and our drawings that the quick way to solve a multiplication of fractions problems is to simply multiply our denominators and get an answer, and to multiply our numerators and get an answer as well. Okay, I'm going to show you where that comes from again and explain it just straight out for you, and then we'll solve the problem and you can get on with your day. All right, so I'm going to start, of course, with the drawing. Since it is 3/4 of 2/3, my drawing is going to start with 2/3. So I'm going to just start by drawing a box, and I'm going to split it up into thirds, and I'm going to shade 2 of them. 1, 2. This is my 2/3, right? And there it is. This is my 2/3. Okay? This is where the problem begins with 2/3, and we get 3/4 of it. So what I would do is take one of my thirds and split it into fourths. As the fraction tells me, I get 3/4. So I get 3 out of those 4 pieces. So I'm going to double shade 1, 2, 3. And then because I also have another third right here, I'm going to do the same thing with that one as well. 1, 2, 3. And as we learned back in first, second grade, all fraction pieces must be the same. And so they end up with a drawing that looks a lot like that. And that drawing demonstrates our answer. Okay, we have 3/4 over here on this side, right? And if you count up the amount that's double shaded, it shows 6 pieces. We made 6 small pieces that we get to keep. But out of the whole thing, it shows that we created a 4x3 rectangle, which means we have 12 pieces. Okay, so our answer here is going to be 6/12. All right, what do we do? Where does this algorithm come from? What does it give us? Well, check it out. When we found that pattern, that 4 times 3 ended up giving us this denominator correctly of 12, what did we really do? Well, when you do 4 times 3, or whatever the denominators are, what you're really doing is saying, hey, we started with 3 large size pieces, and we sliced each one into 4 smaller pieces. Since we did that with all of our thirds, we created a grand total of 12 pieces in the whole. So I'm going to write this. The algorithm of multiplying our denominators gives us the number of small pieces in the whole. And when you multiply your numerators, you find the amount of small pieces that you actually get. Because we took our 2/3, which were here and here, and we ended up getting 3 small pieces in each of them. So 3 from this one and 3 from this one, for a grand total of 6 smaller 12th size pieces. So this is the number of smaller pieces we get. Okay, and this equals 6/12. Okay, so there's a quick lesson. I will be on our Google Classroom, our Hangouts later for you. That's it.